is one of your examples from your homework. One of them's a little different, and I didn't do a guided practice to match one of these scenarios. So I'm going to do it for you. I'm only going to graph the one that has the little irregularity in it. That's x minus y is less than or equal to negative 2. So x minus y is less than or equal to negative 2. You could graph that by finding the x and y intercepts if you'd like, or you could do it by slope-intercept form. I'm going to model both for you. So if you're going to graph this using y equals mx plus b, you're going to move the x term. So what happens when you go to the other side? You change your sign. That's pretty much like the other ones we've done. Now you need to divide by the coefficient in front of y. This is a negative 1. And if you think back to when we graphed just single linear inequalities, what happens when you divide by a negative? You have to reverse the inequality. And here, remember your imaginary negative 1? Negative 1 over negative 1 be a positive 1x, negative plus 2. So this is what you have to pay attention to. When you divide by a negative, notice your inequality reverses. So to graph this, it's a positive slope. It's going to be solid because it has that equal sign there. Up and to the right, down and to the left. That will give you a positive slope. Plot your y-intercept, b, your beginning. It's 2, 1, 2. Let's count up your slope. Up 1, right 1, up 1, right 1, down 1, left 1, down 1, left 1, down 1, left 1. Solid line. Now I'm not going to graph this one because that's like the guided practices, but I did mention you can graph it by finding your x and y intercepts. If you were to make x 0 and y 0, when x is 0, what is your y-intercept? Positive 2. When y is 0, what is your x-intercept? Negative 2. So that's another way you could graph it, not having to put it in y equals. Now let's do our shading. Y is greater than, that means it's on top. So if it was raining, where will you get wet? If you're on top of the roof. There you go. You will have to graph the other one to find the final solution.